So for number 1 on the 3.6 part 3 worksheet, essentially this is combining all the parts from the previous worksheets and putting them into one giant problem. So we are doing a complete graph analysis of these. So really my first step is to factor this. So before I do anything else, I want to factor. So the numerator factors to be x plus 5 and x minus 2 all over x plus 5 and x plus 3. So this is going to be x minus 2 and x plus 3. So this is our new version of the function. This is the one that I'm going to be referring to throughout the entire problem, except for part A, which is the wholes, because the x plus 5's canceled out. So because the x plus 5's cancel, that means that there is a whole at x is equal to negative 5. But then I am going to be referring to the x minus 2 over x plus 3 version of the function. I'm not going to be referring back to the original function. So for part B, to find the x-intercepts, we need to set the numerator equal to 0. So x minus 2 is equal to 0. So x is equal to 2. And if I write that in ordered pair notation, it is 2, 0. To get the y-intercept, you want to set x equal to 0. So if I plug 0 in wherever I see x, then this is going to be negative 2/3. So as an ordered pair, that would be 0, negative 2/3. Okay, so if I look at part D, to find the vertical asymptotes, we want to set the denominator equal to 0. So I'm going to take x plus 3 and set it equal to 0. And x is equal to negative 3. Again, this is not a point, this is a vertical line. This is a vertical boundary in the function. For part E, I want to compare the degree. So the numerator has degree 1 because it's just an x. The denominator has degree 1 because it's just an x. So they are the same. So I need to form that ratio, and it's the ratio of the leading coefficients. So there's a 1 in front of that x, and there's a 1 in front of the x on the bottom. So it's just going to be 1 over 1. Or you can just say 1. So the equation y is equal to 1 is going to be your asymptote. For part F, this is the domain. We haven't had to deal with this yet in this section. The domain is the x values, and it can't be the vertical asymptotes or the wholes. So we do need to express this in interval notation, and I basically just need to exclude negative 5 and negative 3. So I'm going to start at negative infinity, work my way up to negative 5, put a parentheses, put a union, work my way from negative 5 to negative 3, put parentheses and a union, and then work my way from negative 3 to positive infinity. And this would be the domain of the function. Going to part G, now this is kind of odd because the asymptotes are supposed to be boundaries in the function, but we can actually cross a horizontal asymptote. And it usually happens in the short term, meaning more locally towards the origin. As we go out towards the infinity, towards the end behavior, it won't cross it, it'll still approach it, but in the short term it is possible potentially to cross it. So to figure out if it does, we need to set the function equal to the horizontal asymptote. So if I set x minus 2 over x plus 3 equal to the horizontal asymptote, which is 1, and I'm going to express that as 1 over 1 because I am going to solve this like a proportion. So if you cross multiply, then this will be x minus 2 is equal to x plus 3. And then if you solve, the x's actually go away, and you get negative 2 is equal to 3, which we know that that can't happen. This is false. So it doesn't cross. And then lastly, part H, we need to graph the function. So I want to graph the entire function, really using all of the data that I have. So I know my asymptotes are here, and then the y-intercept, well, not the asymptote, sorry, the intercepts. So this is going to intercept at 2, intercept at negative 2/3. It doesn't need to be perfect. I know I'm going to have a asymptote here, and asymptotes we use the dashed lines. I know I'm going to have an asymptote here, and then I'm going to draw my function. So it's going to look like this. And you can really graph it on the calculator to get a better idea. I don't care if you graph it on the calculator, but you still need to show all of your algebraic work. And the other thing is we know that there's a hole at negative 5. So at negative 5, I do know that there's a hole. So this part of the graph would look like that. Okay, so a lot of work on these. WebAssign will ask for the range. I will overwrite it so that it makes that part of the question worth 0 points, because I don't care if you declare the range. It's a little bit tougher to find that. So WebAssign will still ask for the range, but I'll make it worth 0 points.